Hey guys, Coach Shark back. Um, just finished the other video and now I'm doing these last 7 problems, and honestly looking at it, and I was trying to divide the work up evenly, but you have one multiple choice answer left, and if you've already looked at it in the packet, you've got 6 kind of short answer questions after this. So I probably should just include this one with the last group, but it's okay. All right, so last kind of multiple choice question. The diagram below, circle O, GO right here is 8. So again, since we're going from the center to the edge, that's the radius. Angle GOJ is 60 degrees. What is the area in terms of pi of the shaded region? So we don't want the area of this sector. We want the area of the rest of it. So again, y'all had a couple problems like this on the area and arc length worksheet. I kind of told y'all not to just do this section, but this is still a sector, the shaded area, all right? It's still a portion of the circle. If this is 60 degrees, then let me get my paperweight down again. This is the rest of the circle, which is 360 minus 60, which is 300 degrees. The radius is still 8, so I could still do the area of a sector with a 300 degree angle. All right, so here's our formula for area of a sector. So what I'm actually going to do is I'm going to split it up how I've showed y'all before. I'm just going to do the theta over 360 times pi r squared. So I want the area times whatever portion I'm doing, right? So theta is 300. So 300 over 360 times pi 8 squared. All right. Okay, so 2 things we got to do. Let's go ahead and square that. So we got 64 pi, right? And then let's simplify this fraction because I think that's going to make it easier. Okay, so you can knock off the zeros, and then you got 30 over 36. Both of those will divide by 6 to give you 5/6. But again, if you don't remember how to do that, and I'll show you again, if you don't have the blue calculator, you might not be able to do this, but I know I'm not centered here. All right, so turn it back on. All right, clear it from the last problem I did. So we're going to do 300. Oh, did 3,000. Delete. All right, A, B, C. That's your fraction button, all right? So it does the little fraction thing. 360. It equals, simplifies it to 5/6. Okay? Again, if you don't have, the calculator has the ability to do that. The zeros cancel, and I've got 30 over 36. Those both divide by 6. So I've got 5/6 times 64 pi. Okay? If I multiply this into the numerator, I've got 64 pi times 5. 65 times 64, again, you can punch it in your calculator. It's going to be 320 pi over 6. So I should be able to reduce this, and I think it's kind of obvious from your answer choices. They all have a denominator by 3, denominator of 3. So I got to reduce this to 3, which of course would be dividing by 2. Can I divide the numerator by 2? Of course I can. So I divide both the numerator and denominator by 2, which will give me 160 pi over 3, which is D. All right, so let's go to the short answer. All right, so number 25 is mixing in a couple different things. As we got, it's going to be dealing with angles and arcs inside a circle, but also something else. So let's read the problem. In the diagram below, circle O with diameter BC and radius of OA, chord DC is parallel to chord BA. So it tells you these are parallel. And again, if y'all remember, the symbol for parallel is the same number of arrows on the line. So those are parallel. Okay, so if you sit here and think about it, yeah, it's kind of hard to tell here, but if we can kind of turn this sideways and you can get rid of this radius and the circle. I know I'm doing the sideways, so I'm going to do it over here so y'all can maybe see it a little better. All right, I've got BA here. I've got DC here. And this is the line that goes through it. So you really have two parallel lines in a transversal. Again, if these were to go, oh, that's bad. Yeah, I was looking through the camera there. So just kind of ignore that. All right, so there's the points. But again, I've got two parallel lines. Let's say the transversal keeps going. So still two parallel lines of the transversal, right? Oh, there we go. I wasn't even on it. Two parallel lines of the transversal. So we got to put it back in context into the circle here, okay? If we look at it, it tells us the measure of angle BCD is 30 degrees, okay? So that's BCD is 30, right? So again, if we come look at kind of the drawing I did here, here's BCD, this is 30. And employing our rules of parallel lines with the transversal, well, actually, I guess I better tell you the angle you're looking for first. AOB. Okay, so we're trying to get angle AOB. Okay, so the key with this is that I'm going to use alternate interior angles to make this 30 degrees. Okay? So I know that this is 30 degrees. Okay? So again, you got to make the assumption here, okay? So this is going to be kind of tricky. If we were to go the other way, so now AD is also a transversal here. Actually, I thought we were looking for a different angle, if I'm going to be honest. I don't know if y'all can tell the sound of my voice. I thought it said AOC. Oh, boy. All right, give me a minute. I got to figure something out. Okay, no, I got it. All right, I got it. So, yeah, that's key. All right. You actually didn't even need to do this, actually, if I'm being honest. You didn't even need to do 30 out. I'm looking at it. All right. So, well, actually, I guess you need to. You need to because that line wouldn't have been here. All right. So, we're going to say that. All right. So, this is 30 because of what I said. Okay, we're back on track, right? Okay. So, this 30-degree angle opens up to this arc. I'm not centered. This 30-degree angle opens up to this arc. This is still an inscribed angle. We've talked about inscribed angles. This is half of my arc measures. This arc is going to be 60 degrees. Okay? It means this angle is 60 degrees. So, yeah, there we go. I don't even need this part. All right, so this is a straight line, right? So now if we kind of turn it sideways, I didn't even actually need this part right here. All right, so if we turn it sideways, this is 60. This has to be, this is a straight line. So this angle have to add up to 180. So we would do 180 minus 60, which is 120. So our answer is 120. And if you want to kind of write it out a little bit, we're going to say use parallel lines with a transversal. You don't necessarily have to write it out like this, but they wanted to give you a little space. So we did work it out, but I'm kind of writing it out. And then alternate interior angles to show my paperweight. What angle is that? That is, we'll say CBA. To show angle CBA is not even anywhere near frame, 30 degrees. Okay? So then we're going to say, we're going to use inscribed angles and arcs to show arc AC is 60 degrees, okay? So we're going to use central angles to show angle, what angle is that? COA? We'll say AOC to make it kind of match. AOC is 60 degrees. And then the fourth step, we use linear pair to show angle AOB is 120 degrees. There we go. All right. Directed line segment PT has endpoints whose coordinates are P, so -2, 1. So -2, 1. And T, 4, 7. So let's see here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay? Determine the coordinates of point J that divides the segment in a ratio of 2 to 1. All right, so here's the thing about this. Again, we're not trying to find the whole distance here. Okay? Coordinate J, if we drew a line here, is somewhere on here that divides it in a segment of 2 to 1. Again, it's direct line segment. This is going way back to the beginning of the year. So we're starting at P. We're dividing this basically into 3 parts. The first 2 parts will happen, and then you'll hit point J, and then the third part will happen, okay? So what this is going to come back and do is use the partition of a directed line segment. Again, I haven't seen this in a while. I showed y'all this one. I think that's easiest. So again, we got 6 things that we got to identify. The x coordinate of my first point, A and B are from my ratio, x coordinate from my second point, y coordinate from my first point, y coordinate from my second point, and then you've got other stuff that repeats. So let's look at the problem, okay? There's x1, y1, -2 and 1. This is x2, y2. Okay? And the ratio is 2 to 1. Your first number is A, your second number is B. All right? So it's going to be kind of a long written out formula here, and we're going to have to simplify some math, but we can do it. All right? So let's start with the first part. We'll start with everything up until the comma halfway. So I've got x1. All right? x1 was -2. So I've got -2 plus ratio. A over A plus B. So 2 over 2 plus 1, which is 3. You can show the 2 plus 1 if you want. I'm just going to go ahead and make it 2/3 times x2 minus x1. x2 is 4, x1 is -2. All right. So everything I just wrote, I'm going to show it over here. That's going to give me the x coordinate of the point I'm looking for, J. Okay? So I'm going to put my comma, because that's going to separate it from my y coordinate. Y coordinate, same thing, except you just replace your x's with your y's. So I'm going to start with 1 plus, ratio stays the same, 2/3, 7 minus 1. You know, so y'all going to see, again, they probably did this on purpose, but we got kind of lucky. Okay? All right, so I'm going to start with a little math. So we got to go to the innermost parentheses first, which are these two. Okay? So it's going to give me -2 plus 2/3. 4 minus -2 turns into 4 plus 2, which is 6. 1 plus 7 minus 1. So 2/3 times 6 again here. Both of these are going to wind up being the same. 2/3 times 6. What's 2/3 of 6? That's 4. So I've got -2. Where's my paperweight? -2 plus, multiply that is 4. And then 1, same thing, plus 4. So now just do your math. -2 plus 4 is 2. And then 1 plus 4 is 5. So 2, 5. So let's kind of map that and see if it kind of matched up. So there's, oh, I'm looking at paper, so I look through the camera. All right, 1, 2, 1, 2, 3, 4. All right, as y'all can see, my drawing was a little bit off, but it was pretty close to the line. So again, drawing's not gonna be perfect. I don't have a straight edge, obviously. Probably could, grab something and used it, but it's good enough. All right, so our answer is 2, 5. All right, 27. As graphed on the set of axes below, triangle A prime, B prime, C prime is the image of triangle ABC after a sequence of transformations. Is A prime, B prime, C prime congruent to triangle ABC's the properties of rigid motion to explain your answer. Again, we've called out a few different names, but that's saying all of our transformations that produce a rigid motion produce a congruent figure. So that's translations, rotations, and reflections. Okay, so you can look at it kind of one or two ways. Okay, if you rotate it, it would look like it'd be a rotation about 180 degrees, but if you rotate it, point C would kind of wind up pointing up like that. So it kind of look like that. It wouldn't match that. So I'm seeing it as either you can reflect it over Y and move it down, or move it down and then reflect it. I mean, it's the same thing though. So I'm going to say I'm going to try to reflect it and move it down. Okay. So if you look at your points for A, B, and C, A is at, if you count it out, A is at 3, 4, B is at 4, 2, and C is at 1, -1, right? So 3, 4, 4, 2, 1, -1. Okay, if I'm flipping it, again, this is where you don't really need the what's telling you to do to your coordinates. Because, let's think about it. If I'm flipping it over the y-axis, I'm not changing what y is up or down, right? I'm just changing my x from +3 over here to -3. So I'm just changing all my x's, right? So if I were to reflect over the y, I would get -3, 4, -4, 2, -1, -1. Okay? So let's look at my 3 points now. A prime, B prime, C prime. Okay? A prime wound up at 1, 2, 3, -3, 1. B wound up at -1, -2, -3, -4, -1. And C wound up at -1, -1, -2, -3, -4. Okay? So all of our x's are the same. Let me get my thumb out of there and my finger. All my x's are the same, and my y's, I subtracted 3 to get there, subtracted 3 to get there, subtracted 3 to get there. So we're going to write this up. We're going to say, yes, they are congruent, which can be shown by a reflection over the, getting ahead of myself, the y-axis and translation of 3 units down. And you actually could have flipped the order of those first. You could have done a translation of 3 units down here and then reflect over the y-axis, and it actually would have given you the same thing. All right, so I know I got stuck on that one problem. I'm almost at 20 minutes already on this one, so let me try to hurry through these last 3. Next couple, I believe, are trig ratios, so it should be pretty easy. Carpenter leans an extension ladder against a house to reach the bottom of a window 30 feet above. So here's the window. We showed the 30 feet over there for some reason. God only knows why. As shown on the diagram below, the ladder makes a 70-degree angle with the ground to the nearest foot and determines the state and length of the ladder. We did a lot of problems like these when we were doing this, right? So again, bottom of window 30. I don't know why they're showing it there. Let's put it here. If you really need to, paper of 8. If you really need to draw it separate, All right, there's your right angle. This is 70 degrees. This is 30 feet. So I'm trying to find the length of the ladder. Again, the ladder is leaning against the house, so this is going to be the length of my ladder. So we're going to, looking at 70, label opposite, adjacent, hypotenuse. I'm dealing with opposite and hypotenuse, which is sine. Sine. So we got sine of 70 equals, trying to keep this centered, 30 over x. All right, so again, we got to remember here, I can either move my denominator out in front or flip it with what's over here. If I move it out in front, that would give me x sine 70 equals 30. That doesn't really help. But if I switch them out, x is going to come over here, give me 30 over, paperweight not working, over sine of 70, which I can punch in my calculator. So let's do that. All right, so 30. I'm just punch this in my calculator. I'm trying to look at it under my phone. Divided by the sine of 70 gives me 31.93. It says to the nearest foot, so we'll round that up. I'm going to put the 31.93, which we'll round up to 32 feet. All right, last two. Okay, so when instructed to find the length of HJ, let me get the problem up here. I'll probably help you out. Instructed to find the length of HJ in right triangle HJG. Alex wrote an equation, sine of 28 degrees equals HJ over 20, while Marlene wrote cosine of 62 equals HJ over 20. Are both students' equations correct? Explain why. Well, so you're looking at this evaluate and you're saying, okay, well, I should be able to prove that's actually sine or not because I have 28. I know HJ is over here. Here's 20. So let's deal with that first, okay? So if I'm looking at this being 28, right? This is my opposite side. This is my adjacent side. This is hypotenuse. Again, we're trying to find HJ. So I'll put an X over here. If you want to cross out the HJ there and put X to help you out, that's fine, but that's still the same thing. So opposite over hypotenuse. I'm looking for HJ. Hypotenuse is 20. So again, we just use sine. So that would indeed be sine of 28 equals HJ over 20. So Alex's checks out. Okay, Alex is good. Marlene wrote cosine of 62 equals HJ over 20. Well, where did she get 62? Hopefully y'all can figure it out that this is 90 and this is 28. The other angle has to be 62. So again, let me put my paperweight down. All right. So now I'm going to do this. Again, I'm looking at my work more on the phone, realized it was not in frame. All right, so there's my right angle. If that was 28, we said this was 62, right? This is still HJ, that's G, and this is 20. All right. So same triangle, except now I'm looking for 62 right here. Now if I'm looking at 62, now GJ is opposite, HJ is adjacent, and 20 is my hypotenuse. So HJ over 20 is adjacent over hypotenuse, which is cosine if we look. So they are actually both correct. All right, Marlene's checks out too. So I'm going to say, oh, Siri wanted to take over for some reason. Sorry about that. All right, so we're going to say that yes, because my third angle is 62 degrees. And what we're actually going to do is, even though I drew it out, this is the justification I'm going to use. You could draw it out and that's fine, but if we remember, we got to use the complementary rule of our trig, all right? So using our complementary rule, so sine of angle A is equal to the cosine of angle B if A plus B equals 90 degrees, which we have here. 28 plus 62 is 90. So that's what you could say for the rule, but we also drew it out and proved it, so either of those would kind of work. All right, number 30. Last problem. All right. The diagram below, tangent DA and secant DBC are drawn to circle O from external point D such that arc AC is congruent to arc BC. So again, we just, this is one of the last things we did. We did this, and then we done arc length and area of the sector of the circles, and then volume. Well, we also did the segments, but we did this in February, so should hopefully be relatively fresh. All right, first thing it tells us is AC is congruent to BC. So I know arc BC is 152, right? So arc AC has to be 152. There's only one arc left in the circle, AB. All three, of course, have to add up to what? 360. So if we add those, paperweights, that is 304. So I've got 360. Again, trying to look through the phone. Paperweight's not really working. 360 minus 3, that's 4, not 9. I said 4, so don't mess that up. Try that, that's 56, right? So now this arc is 56 degrees. Okay. So to get my exterior angle, I have to, again, this is not on your formula sheet, so it's something you're going to have to remember. I got to take half of the difference of my arc. So big arc minus the little arc. All right. So I got to do half of, again, this is the big arc that it opens up to. It touches A and C. So this is the big arc. This is the small arc. So I'm taking half of 152 minus 56. Well, if I subtract that, it's going to give me half of 96, which is 48 degrees. So there we go. So that's all you need to show for that one. All right. So packet for week 2 is done. Again, if you happen to look at this Monday morning, I will, after I send out a message on Remind, I will post this week's work sometime tomorrow. So what we're going to do for now is it's not necessarily its own practice test, but it's a giant PDF, 200-page PDF. I might have talked about it briefly during class. There's over 600 questions. I might even show a couple, y'all. Definitely not going to have to do it all by the end of the year, even if we're out that long. We're thinking 10 problems a day. So again, it's kind of pretty much on par with what y'all been doing now anyways. So I'll let y'all know for sure the next day or two, but I'm going to post it regardless and go ahead and tell y'all to start doing 10 problems a day as it is right now. And I also want to get a Zoom meeting potentially, or at least another Instagram Live going this week. Let me turn this around so y'all can see me. Yeah. So I want to get a Zoom meeting or Instagram Live, Google Hangout, something this week, just so I can kind of actually see y'all and interact with y'all. So again, I'll try to get some input on that tomorrow. See if y'all want to just do one big one. Cause again, even with Instagram Live, I had maybe 30-35 people pop in and out. Again, hopefully I would have more than that, but it's kind of, even if I got max capacity, we did this in one of our faculty meetings, max people would be allowed to be 100. So, I also don't want to, I got to look at it. But again, if I do it per class, only have 6 or 7 people show up per class. I feel like I could have just done it as one. So again, I'll look at that and let y'all know. So I will hopefully see y'all at some point this week. If y'all don't pop in, just, keep checking your mind, keep sending me your questions, and keep doing your work. Until then, this is Coach Sharf. Peace out.